Hello all, we are here for one more lesson of this VariCAD 2016 training course, and the topic for this lesson it is about geometric constraints. Basically, geometric constraints are degrees of freedom that we can have or not in any object in space. So each object can have 6 degrees of freedom, 3 of them linear and 3 other rotation. So let me make you a very quick example to explain you this idea, and I will make two solids, simple ones, and the normal situation it is if you want to change one of the solids, transform it so they have no relation, they do not move having the other in consideration. But if we apply a geometric constraint, we can link them in many other ways. So for that I have these two functions, the geometric constraints between solid elements and between solids. They have the same behavior. In this function here we are talking about different elements inside one solid. For this function we are talking about relation between solids, for example, in one assembly. So this is something that you can use as a concept in the future for your assemblies. So for example here I say I want to apply a constraint to this solid, and I get this dialog box for applying these constraints and make its definition. In this first part I can check what are the degrees of freedom that are taken out from the solid. Okay, in this particular case I have no definition, so everything is completely free. And then I have the relations I can apply to the objects, like for example the distance in one of the axes to the insertion point of one solid. For example, I'm pointing to this one here, so in the Z I can apply to this solid. This is the distance that we found, let me say 100, okay, and just say apply. Now I have a relation that every time I try to move this object here, the other will follow, because it's said that has this 100 millimeter relation. Okay, this is the concept. For example, this is constraint, you see here as a linear movement. This is constrained in this axis, but the other ones are free, because when I try to move this object, for example, in this axis here, there is no problem, because the constraint is only on the other axis. So this is something that you should understand, that every time you take 1 degree of freedom in one of the 6 different possibilities, the others are still free. Okay, let us make a very quick example of the possibilities. Again, let us make one very simple solid, okay, box with different values for each one of the axes. And now I will create one additional solid and will apply something that we call additional rotation. And the additional rotation, it's used to apply an angular constraint. I forgot to create the parameter first, but this is important because I can link these constraints to parameters, which was something I mentioned in one of the previous lessons about this very powerful feature to connect these two things. So new parameters, I will say an angular parameter, just give it a name as A for angle and a value 15, create it, insert it. It is here, perfect. Now let us use the solid, insert it. Let me just define a new point and say the new point should come here. And now I can go and click here in this inner part of the axis with the right mouse button and say additional rotation around this axis, or I could come to the normal functions here. It is the same. And give it an additional rotation around Z axis. And I will choose my parameter. Okay. And what you can check it is that the solid rotated but not the axis, which is very interesting. Okay, and now I can go in this function where it says define or edit constraints after location. Okay, I want to use the constraint, so now it's the time to say I want to apply a cut to this solid. And again, to use this angular additional rotation axis, I need to constrain some other degrees of freedom, which I will do saying this is the y-axis, and I will say I want this here in this surface. So use this function, located patch intersection with y against normal, because the normal is pointing out. So saying this and choosing the surface, and you see now we have constraint in the x on the rotation. Okay, on the y we have this for a linear movement constraint, and we fix it on the direction of y, and again a rotation in z. Okay, you have this new symbol with this little mark here and here that says constraint. So do the OK, it is done. Now a shell, okay, something that we will see in particular in one of the remaining lessons, this kind of solid. And to show you a couple more features, a hole in this solid, I don't care about the diameter. I will position it with one of the functions that we've seen already, and now say 20, make a hole, and minus 40, make another hole. And that's it. Let us see what this does now. I have no relations in terms of constraints for these holes regarding the rest of the solid. So if I edit the solid, for example, doing this, it should not happen anything to the holes. Okay, but for example, I can create relations on this. For example, I can create one relation from this to the according to y, according, for example, to this, and say 40, for example, not this one, I made a mistake, sorry, do it again. Sorry, made a little mistake here. It's this one. Okay, with x, sorry, my mistake. 40, it is done, and do the OK. And what I've done, it was this hole is constrained with this hole, so they will keep always the same distance. Let us try to move them. Let's try to move this guy here a little around here. You see the other one move together with it. Okay, I think there are no constraints now, and we can see, for example, Or I can apply a different constraint to show you that I have several types. One of the types I had, it was according to one of the axes for the insertion point. I can say a distance to a patch, and I will use, for example, this one. I can select this patch, leave this value, I don't care. I can say it located on a patch intersects with the axis, or define a distance for a rotation axis. And here I can locate it on a patch, intersect it with the axis, and do it against the normal or along the normal, and the same for locating it on a circle center against or along the normal. Here it is for the directions of each one of the axes, along or against the plane normal, and the same for directions regarding rotation axis, and here for the additional rotations, which we've seen a part of it. Okay, I've located this hole regarding this patch here, and I can, for example, locate this one here regarding the solid insertion point. I can say, instead of 20, for example, 25. Just do the OK. And now I can change the solid and see if something will happen. If I change to this side, for sure this hole here will move together with the patch. This one was located for the insertion point. It is on the same spot, and now I have no relation between the solid, between the hole, so nothing happened regarding this. So this has a lot of possibilities for you to explore regarding how to parameterize these relations, and having these with parameters also to make this more powerful. I just want to show you one last function, and I leave it to the end. That was regarding this parameter, which you may be asking, why did it do that? So I can go and say, okay, this parameter, instead of 15, I want, for example, let us say 45, and apply the changes. Okay, and you see the solid change completely. And this is quite nice because as you can see, I've just used one parameter to show you these constraints, but for sure we can apply this idea of parameterizing everything, or a major part of your solid together with the constraints, and you can have a really powerful effect on the way your solids move or change every time you need to make a change or a variation or a family part from one that which you may have. So this is very powerful. It's not easy to explain all the possibilities, so these were some ideas so that you can understand the rough basics of these concepts, and for any help you may need about it, please contact us, and we'll try to explain you in detail for each issue that each one of you may put us as question or problem that you have. So I hope to see you in our next lesson, which will be about almost this same topic, the constraints and these relations, but now for the 2D.